So welcome, everyone. This is meant to be the Designing AI Tools subgroup of the UCB AI community. And I have as a reference link to the general page on the UCB AI community. I think most of you know, as so many things in this topic area, it's new. And your hosts today are Jake Tolbert and myself. We are looking after this Designing AI Tools subgroup, and welcome to the inaugural meeting of this group. Jake is with University Development and Alumni Relations, and I'm currently, for myself, I'm doing instructional computing projects across College of Engineering, EECS, College of Computing, Data Science and Society, RTL, and kind of this mix of stuff. Today, we're going to get to check out a really nice, very specific use case of some AI technologies. And to that end, it's my pleasure to welcome Amina Kirby of Berkeley Law Media Services. And she's recently developed an LLM-based Help Bot. And the idea is that this bot is to help with classroom AV technical assistance, especially when the support staff isn't available because the schedule of use of that equipment, spans beyond the typical daily work hours. And so today we'll start with a relatively shorter presentation, not the full hour, but a shorter presentation of her experiences designing and deploying this tool and some considerations and challenges. And then we hope to leave plenty of time for discussion. And I really like this group size because I think we can have a nice, good discussion rather than playing with all that question and answer business. So with that, Amina, would you like to take it away?
Sure, yeah. For everyone who doesn't know me, I'm Amina. I'm the senior AV-IT engineer over at the law school. And yeah, back in about it was maybe September or October, I started doing some research into, as there's more discussion about ChatGPT and just sort of the emergence of LLMs. Started having some thoughts about potentially designing some kind of tool that we could use in our media services department to support faculty who where we may not be as available, oftentimes in the evenings or on weekends if there's ever weekend classes, to basically just design another tool that our faculty might be able to use to assist them with any sort of AV technical issues in the class, whether that be their laptop isn't displaying on a projector, or their microphone isn't working, or they're trying to get Zoom to work in the classroom and it's not working. Any kind of AV questions. The initial intention for designing a tool like this was to assist specifically with AV, and ideally, I was aiming to design something that had very specific knowledge of each classroom AV system. So not just how to turn up the volume on a microphone, but exactly where each button is, say on a touch screen in the room that controls might control an audio or change a camera angle or something like that, or how to turn on the system, and more specifically, like exactly where things are located in the classroom, so that it's really helpful and catered to specific classrooms. So I think one of the initially when I started working on it, my idea was I would essentially just build a big long prompt that I was feeding into ChatGPT. Actually, forgot to pull up the GPTs, the older GPTs that I've used previously. But previously, the first sort of creation of this was a big long text file. I can show a demo of what that currently looks like, or one of them looks like. Basically, initially, I was basically just making a big long text file like this. I was feeding into ChatGPT, and later on, once the custom GPTs were introduced into ChatGPT, I was basically making a big prompt like this that I initially designed to have just specific information about every single one of our classrooms. It's just like a single prompt file. And while it worked okay, there was a lot of things that it was lacking. making a single prompt for all of our classes, it was difficult to provide very specific information about, the classroom equipment, because while a lot of our classrooms are becoming more and more uniform, there's still some classrooms that are quite a bit different than others and have different controls and different microphones and touchscreens and things like that. So a big challenge was both how to create prompts that are tailored to specific classrooms, as well as how to actually manage that information over time as we say, as a system, like an AV system is upgraded. And so we have this, if we were to have like a GPT for each class that has specific information, how do we easily update it over time without going in and just, manually editing a big giant text file is very unruly and makes it difficult to maintain. So a solution I came up with to get around this was I basically put together a big long Python script for folks who are familiar with Python or have used Python previously. It's a programming language. I used Python and basically broke up the prompts to individual chunks that certain classrooms may use. So, certain classrooms may have common equipment like common microphones or common cameras or common ways to control them. So there's certain sort of similarities that different classrooms will have that in this script, I broke those up into individual chunks, and then at the end of the script could then create an individual prompt for each room where I could say, okay, this is classroom, say number 10. And I could add each chunk of the prompt to that to make it tailored to a specific class. So I don't think I'll pull up the actual Python prompt right now, but essentially, similar to how this big prompt works currently, the script itself looks similar to this, except it's just an even bigger wall of text because it has, individualized chunks of text that I'm then using to combine into a more unique prompt for each classroom. Yeah. So initially, I made this script and I was able to make it produce unique prompts for each class. And was like, oh, this is great. I have all these individual prompts. So I initially created a big list of GPTs within ChatGPT that I was then continuing to test. And as I was testing it, and as the AI group was formed, and I began working with people like Greg to further test some of the GPTs I put together, it became clear as far as how we were going to be deploying it that there were definitely a lot of difficulties or challenges to sort of figure out as far as how to get it to behave in the right way. Something also to note about this, so the idea of how we would be deploying this project would be on iPads in classrooms. So each of our classrooms has an iPad with a few different AV help tools. Like there's a tool to call media services if they have a technical issue. There's a help page, and then so this would be another tool on the iPad that would be used by faculty to talk with the GPT. So not only is it a chatbot, but it's a chatbot that's accessible by multiple people. So if somebody say, depending on how we were implemented, if somebody say were to walk into a class and get the chatbot to start talking about something completely unrelated or something potentially offensive, or something completely unrelated to AV, it was a challenge to sort out how do I create something that allows every time somebody asks it, they get the same prompt training, basically the same experience each time someone is actually interacting with the GPT. And the main solution I came up with for that, initially, I was working with the OpenAI API, and then using an app within the iPads called iPad Shortcuts. So Shortcuts is an app that allows you to, it's kind of a programmatic language, but it's a very simple version of it. But allows you to do things like make calls to other websites, like to OpenAI. So we could set it up so that rather than having a full ChatGPT on each of our iPads, it could just be a shortcut that's actually just sending questions and then receiving answers back and forth from OpenAI. So that was the next step that I sort of moved to as far as how to actually implement this in a safer way on our iPads that would ensure faculty would have a similar experience. And while that worked, there are definitely some issues with it, and some of which were security. So when making an API call or making a call to OpenAI from the iPad, there was a certain token or in this case, it is called an API token, essentially like a credential that's required for an external device to communicate with the API that we had set up on OpenAI. And due to there's no real way in iPadOS shortcuts that I had found to obfuscate that credential. So essentially, if somebody was sort of poking around one of our iPads, they could potentially open up this shortcut and look at the details for it and find our API credential, which is not good. So that method was proving a bit, still not ideal. So after working with Greg on it a bit, and the next step I started looking into is potentially creating a tool like this on Azure, so that rather than our iPads communicating directly with OpenAI, it would instead communicate with Azure, a virtual machine on Azure, which is then communicating with OpenAI. And then once it receives a response, then it sends that back to the iPads. So that way there's no credential that's being sent or that's being stored on the iPads. And then also it allows us to have more control over both the questions being sent to Azure, as well as some security things we can set to basically limit what devices can actually communicate with the API on Azure in the first place, as well as restrictions in what kinds of traffic can interact with the API. One note also, so another similar on this topic, and a big issue that became apparent very quickly when designing a GPT was that essentially, regardless of what kind of training I was providing a GPT and how many times I told it, never do this thing, never do that, like no matter how somebody asks it, just never do this thing. Essentially, like if somebody has an infinite number of questions they can ask a GPT, essentially it's almost impossible to get a GPT to 100% all the time act exactly how you're wanting it to act. So finding a way to basically limit the number of responses seemed like the only way to really wrangle that kind of behavior in, so somebody couldn't get the GPT to ultimately just do whatever they wanted it to do, basically. So that was also another benefit to moving to more of an API like on Azure, as opposed to just having a GPT set up on like a web browser or something like that a faculty can communicate with that way. Because thus far, OpenAI, there doesn't seem to be any kind of limitations as far as limiting the number of questions, or really designing something that's designed more for like a customer service environment, where you may have somebody interacting with, say, like a chat kiosk or something like that, which is more sort of what our use case has been in the law school, or what will be once this is implemented. So here's a PDF that sort of just outlines how the AV Help Bot is currently set up. So we have each of our classroom iPads. And then, so I'll step back a second. Actually, prior to showing this, maybe I'll just demo now sort of what the current bot looks like on the iPad. So let me just share screen on this iPad real quick. Yeah, so this is what all of our iPads look like. having a very standardized iPad layout has been very important as far as faculty being able to look at one iPad and knowing exactly what's on it when they go to another iPad. So all of the apps on our iPads are basically located in the same folders in the exact same position, so that if I were to train our chatbot to say know exactly where all of the iPad apps are, it would be able to tell a faculty. So say in this case, a faculty wanted to know where the PowerPoint app was. So if I were to select the AV Help Bot like this, it's asking me if I want to talk to it or type. So they can either talk with it and say, I don't know where PowerPoint is. But in this case, because it's connected to Zoom, the talk option won't actually work. So I'm just going to select type. So if I select type like that, and I say, I can't find PowerPoint on the iPad, like that. So if I send that, and you'll notice this next step will actually take sometimes up to 30 or 40 seconds. And the reason for that is because currently the chat model that's being interacted with is GPT-4, which is a bit slower than GPT 3.5. GPT 3.5, if I were to change this to 3.5, the response is almost instantaneous. Whereas 4, depending on the length of the response, can sometimes be quite a bit longer of a wait time. But you'll see, so the response, PowerPoint is located within the presentation folder on the iPad's home screen. Simply locate the presentation folder, tap to open it, and you'll find the PowerPoint app inside along with other presentation-related apps. So yeah, this is something that a part of the training that I received where I basically in the part of a prompt that basically says, here's where all the iPad apps are located. Here's all the folders and each app within each folder. So if faculty ever asks a question like that, the iPad can tell them exactly where the app is located. Some other questions, like if a faculty were, say, having issues setting up their Zoom and they wanted to ask, how do I use this classroom for Zoom? This is an iPad that's currently set up in my office, although it's been prompt trained with one of our classroom prompts. So it's imitating essentially what one of our classrooms, the AV layout in that classroom. But you'll see here, so this basically, based on the equipment in that class, is providing directions on how for the faculty to get their own personal computer plugged into our classroom system and have it set up for Zoom, and which audio sources and video sources to select when changing their audio and video sources in Zoom. Great. And so another thing, if I were to continue asking the bot questions, after 5 questions, there's it basically posts an alert that says you've reached your maximum quota. And if you need further assistance, please contact media services. Or if they needed to continue talking with the bot rather than us, they would have to restart the conversation. So, if a faculty, say, had a question that had then a follow-up question, like say if they said, great, I'm connected to Zoom, say, but I don't hear the classroom microphones. So the bot will also, for the quota 5 questions, it will also still remember previous questions that were asked up until either this specific session is ended with the bot or they've reached that 5-question quota. So this isn't with the intention of basically preventing someone from, as I mentioned before, having an infinite number of questions and essentially kind of social engineering the bot to do all sorts of things, like get it to talk about cupcakes or anything they see fit. And so just to give a little bit more detail about on the back end, sort of what's actually happening when the iPad is communicating with the bot. So when a question gets sent out, the iPad basically sends a packet of data. In this case, the packet of data is packaged into what's called a JSON. For folks who aren't familiar, it's basically a type of basically a packet of information that you can categorize, put labels on different basically create sort of a list of values. Yeah. a list of values, which then the bot can, the bot which is on the Azure VM can take and sort of analyze and parse out different things, like parse out, say, a question. And then, so basically when an iPad, someone asks a question, it gets sent to the VM. It takes the JSON file and pulls out the most recent question, which it then sends to the Azure OpenAI. So this is the actual question being sent to the LLM model to then create the response. Something else to note, depending on the name of the iPad, so the actual, folks are familiar with naming, different OS devices. Depending on the name of the iPad, the VM will also use that information to determine which prompt to select. So on the virtual machine, there's basically a directory with a list of specific prompts for each of the classrooms. And depending on the host name of the device, which say, in this case, might be iPad A, if the VM sees, oh, this is iPad A, so I'm going to pull the prompt for classroom A, and then put that into the query, which is then sent to OpenAI. Basically, to ensure that depending on where the iPad is located, that the correct prompt is used when asking a question to OpenAI. And in addition to that, so when both when a question is asked as well as what response is received from OpenAI, that information is all also being stored on another list on the virtual machine, so that over time we'll be able to use some of that information to basically better train our bots over time to ensure they're better responding how we're wanting them to respond to faculty. And I should also mention, as far as any concerns about security with our bot and what sort of information we're actually training it on, pretty much all of the information that we're using, it's kind of in our case, basically we're just providing very detailed information about how our AV systems work and how someone would use them. So in the worst case scenario, if a bad actor were to say want to have our prompts or our bot spill the beans and basically share its entire training prompt, all they're really learning is just how to really use our AV systems very well. So there's no FERPA information, there's no PII or anything like that. It's all very basic information that a lot of times they can just find on the Berkeley Law website. So in that case, there's a lot less concern in our use case to really take that into consideration, apart from just simply limiting the number of responses people can have. I would say, anyone who's designing a bot that may interact with more sensitive information, there's a lot more to consider and think about before you'd actually want to implement something like this, because as I mentioned before, any bot like this is very easily engineered to do all sorts of things you don't want it to do. So this is kind of the layout of how the bot all works. Any kind of changes to the virtual machine I can just make remotely from my laptop. So I can just remotely connect to the virtual machine and make changes as we need to, or upload new prompts. So if you need to update a prompt, also pull up a few sort of quick commands I've created to, once I say generate a new list of prompts from the Python script I mentioned before. So here's, say, a folder full of all the prompts. If I want to move these to the virtual machine to be used with the bot, I've created a few different sort of shortcut commands that, just by running one of these commands will transfer all of the new prompts to the virtual machine and then erase the old ones. So it makes it very easy and straightforward to, update all the prompts if we say wanted to add something like, oh, we're changing our working hours, or, oh, we want to add another little section about making sure that the system's powered off after folks are completed with it. It makes it much easier to sort of create and add changes over time as we see fit. Also, just to show what some of the response data looks like, I mentioned before that we haven't done anything with it yet, but currently I've been collecting any sort of questions that are asked, as well as the responses that the bot receives that we could potentially use for future training. What those files look like is essentially something like this. It's just a big long list of questions and then the responses. How we be planning on potentially implementing something like this into the bots training is something that I've still yet to, we haven't quite gotten there yet, and really haven't gotten a lot of faculty to test this out yet. We're actually currently just in the phase of introducing it to a few faculty to sort of get what the initial reaction and feeling is on it before rolling it out to all of our classrooms. But as we get more data from faculty, then we can get more of an idea of how to better tailor our bots' behavior so that it better serves our faculty. Yeah, I think that's a pretty good overview of everything so far. Folks have questions or comments about anything, or anything I'd be interested in me going over in a bit more detail? Or
Thank you. This is super cool. I mean, I think I just want, just as a little note, kind of from my perspective about, what you've done in a sense, in one interpretation is, so I think there's a fascinating mix of, in the context of the classroom, a very specific context, this bot is, I'm going to use the word wide open and readily accessible by anybody when they're in that context. And sort of, and when someone is not in that context, there are all kinds of ways in which you can't get to it. It just, take the iPad somewhere else, steal the iPad and hook it up to your home internet. It doesn't work, or, all these kinds of things. And you've also done an interesting, in a sense, where is the app? Where does it happen? You have a bit happening on the iPad, but you have a lot more sort of moved out somewhere else. And you can also do the central management, and you've also, you talked about how the story began in a sense where you were talking about how to maintain the custom information from each classroom. Some information is shared and repeated across classrooms, and some are very specific, and you've kind of built some infrastructure to help do that. And then as long as I have the mic for a sec, I think maybe if I had to sort of guess at some of these, the cloud costs, it's probably, I'm going to guess on the order of $1 a day for that virtual machine, and maybe pennies per conversation, something like that, roughly speaking.
Yeah, to be honest, I'm still sort of wrapping my head around the Azure billing costs. Also, just a quick note, and thanks also to Greg. Greg sort of helped us get set up with some credits on Azure so that I could actually sort of start test running this project. Thus far, from when I initially created the virtual machine on Azure and started tinkering with OpenAI, thus far I believe it's only used for the past few months. I think it's maybe used $150 of the $1,000 of credits that we have. I'd say the biggest cost is actually probably just hosting the virtual machine on Azure. And that's also been with pretty heavy, use with testing and sending, queries over and over and over again to get things really dialed in. As far as the OpenAI usage, from what I had seen, last time I checked, I believe it was a couple weeks ago, it didn't look like the cost was even more than like $4 or $5 for all the testing we had done. It seemed like primarily the main overhead cost was just the VM itself, which is encouraging. But that said, if there was a model like this that was being implemented for, say, like the entire campus, like something like Triton GPT, if folks saw that, I imagine the cost of that would definitely rack up quite a bit more than in our use case, where it's simply existing on iPads in the classroom. And yeah, like Greg mentioned as well, not only is there sort of a check when the iPads make a query to the bot, not only is it checking the host name of the iPad, but also it's checking the public-facing IP address where it comes from. So say if somebody were to steal our iPads and then take it home with them and start trying to send API calls from their home address, or they were to say steal the shortcut from the iPad and then or even just like the URL or anything like that for the that's used to send messages to the bot. Any of that they tried at home, and anything that's not on a Berkeley network, it would not work. So there's some rules. That's another advantage of setting it up on Azure in this case, is there's a bunch of network configuration rules we can set that you can't when you're just communicating directly with Azure or with OpenAI API. So both limited the IP addressing that needs to be received by the bot, as well as the host name of the device.
Jeffrey had a question about using like a Google Chat UI instead of kind of the UI that you've built. I don't know, Jeffrey, if you've got a chance to come off mute, or if you're around, you can maybe add more details, or if you have thought about that, maybe, Amina.
Yeah, I hadn't really looked into the Google Chat. I mean, I'm sure there's some kind of API for Google Chat that you know, as I mean, essentially all this is you know, it's essentially just interacting with a couple of different APIs. One that has been built on the Azure virtual machine, another for the OpenAI API. So really, as long as there's some kind of API for Google Chat, I couldn't imagine it. Imagine it'd be totally possible to make like a chat, like a Google Chat version of this that could then just send like a chat message to like a virtual machine, which could then interact with OpenAI.
I wonder, in such a case, I haven't tried to work with Google Chat or a programmatic interaction, but I could imagine that Google wants to know the identity of the person having the conversation, with a sort of the other end. And would that mean people would have to authenticate, and then could they have long conversation? Would it? I don't know if there are ways to allow the kind of specific control that you've implemented for your context. Yeah, those would be questions I'd have too. Yeah.
Yeah, the Google Chat bots, you can do programmatic things. There are really simple ones where it's basically a question answer, and the answers come out of like a Google Sheet. So you'd imagine like some of a separate rows for each of the different question answer things. So it'd be more if you didn't want. So that case would be if you weren't going to use large language model part of it, and instead we're just going to have lots of fixed answers or relatively dynamic answers, but where you're updating them by changing the rows of a Google Sheet. But the more complicated ones in Google Chat, the bots, you can then host them on the other end with kind of any programming language, even built-in ones like AppScript, and have that talk to OpenAI. So you would cut out the hosting charge for a VM. You'd have a free UI layer. You'd have a free soft programming layer, and you'd only have the charges for OpenAI. So it's getting a little bit more interesting as Google Chat gets closer to parity with Slack, and as they continue their roadmap to think about things like that. But this is cool. It's interesting to see kind of how you did kind of the like retrieval augmented generation, generative AI stuff, but kind of you did it in this way, and it's already done. Versus some people would like, oh, I'm still figuring out what I'm going to use Pinecone, or which database am I going to use for storing all these things. You've already done it, and you avoided a database. You avoided a lot of possible complexity for yourself by just putting answers right there in the prompts. So yeah, kudos.
I mean, I think. Oh, I'm sorry, Jeffrey. I think from previous discussions, I think that those big text files, one for each classroom, with all of the information about the classroom, is that when that starts under the hood, when that starts a conversation, that's the so-called system message.
Correct. Yeah. So for folks who are familiar with the OpenAI API and how you sort of package a message, which is then sent to OpenAI, there's a section before it gets to the sections where it's like a question and then the response, and then another question, another response. So there's a section at the beginning called system prompt, or just system, which when queries are sent, the iPad sends a message to the Azure VM, which then sends the query to OpenAI. When it determines the prompt based on the iPad, the prompt is then put into that system part of the JSON package, which is then sent to OpenAI. in our use case, there's no knowledge base that the bot is pulling from. It's all strictly just prompt programming, basically. There's no knowledge base that it's scraping information from or from our websites or anything like that. Maybe interesting to implement something like that later on if it sort of improves the training, but for the time being, yeah, it's just simple prompt engineering.
I think what this shows is like if you don't have like what we saw with Triton, if everybody saw Triton, if you have a ton of stuff, an entire website or HR's mass of PDFs or whatever, then a more complicated RAG system, obviously makes sense. But if you're creating a custom tool for a very, more of a manageable amount of information, the Amina's technique or custom GPTs or whatever, OpenAI has that other custom instructions, all kind of work a similar way. I think it's just piping into the prompt. Actually works. But I had a question for you, Amina. I know we've talked about this separately, but maybe you can address it. The differences between using 3.5 and 4, the actual differences in the quality and what you found when you were playing with that.
I could potentially demonstrate it, but just describing the differences. GPT-4 is just it seems to just better understand what I'm attempting to communicate often in a lot of the prompts. They're just subtle things like a big issue that I was struggling with when creating prompts for each classroom in 3.5 is something like so in each of our classrooms, there's video cables that are available for faculty to plug into their laptop. And the other end of the video cable is always plugged into a video endpoint that the faculty never interact with and never should interact with. And GPT 3.5 just didn't seem to get it. Like no matter how many times or how I worded saying like, do not instruct the faculty to like plug or unplug the other end of the cable. It doesn't exist to them. Like don't ever consider it. And like I would just start sending prompts and it would still just say, and then check that the other end of the cable is plugged in. So just like little things that GPT-4 just seems to understand exactly when I have said something like, don't check the other end of the cable. It doesn't need any further sort of prompts, engineering or any check that says, do not ever instruct this. It just understands that stuff straight away. So there's things like that are a big advantage to GPT-4. The setback is that the response time is much greater currently. So it's a bit of a trade-off currently where if we wanted the bot to be just like right away, the moment someone asks a question, they get a response back. I could switch it to 3.5, but the trade-off is the quality of the responses basically.
And cost, I guess.
And cost, yeah.
Very.
In the API calls that you can send to OpenAI, there's some other controls that you have that you can't in just like the simple GPT or ChatGPT window, like setting a temperature control. It's basically is a setting to how how creative the bot can be essentially in their responses, like how much it can kind of invent responses and how much it bases its responses on the prompts that are given it. So you can set the temperature. The temperature can range from 0 to 2 is like a value that you can set when making an API call. But if you set it to 0, it can be very very plain, very cold. Just this is what the training I've been given. Almost just like repeating the training without any kind of dynamic response to faculty. Whereas 2, it can, a little more apt to sort of go off the rails as much as it wants. So I think currently I've set the temperature on our bots, all those responses to 1. So it's right between those 2.
Temperature is super interesting.
Yeah.
What about when you get a prompt, a question rather from the users, automatically sending that live to a human as well? Not that the human has to respond, but just so that hey, over in this room, there's something going on. Maybe I should start walking that direction.
Yeah, we have another help tool that if a faculty wants to interact with wants to call a technician for help, which pretty much 9 times out of 10, or really 10 times out of 10 currently, if a faculty needs technical assistance more than what they can get in the classroom, they'll pretty much always want a person there to meet them. So if they need a technician, they already there's a tool in place for them to basically call all of us over FaceTime. At least in my own office, I can set it up so I can basically be monitoring the API on Azure to see anytime there's a question and what the response is. So I can currently monitor it on in my own room. I could potentially set it up so that it could send some kind of message to all of our computers or to like a chat or something like that so other folks are aware that someone's in a classroom asking a question to one of the AV bots.
I think that's a really fascinating question, is trying to imagine a user experience. And there could be so many use cases, right? It could be something, for example, someone felt, they're trying to get their class started. They have a quickie question. They're multitasking and students are coming in or something. And they, let me send this question to the bot because my setup isn't ideal. I'm using this camera, but I want to use the other one. Let me just send the question. Let me do this. Let me do this. And then someone shows up from AVIT and they're like, what? No, I'm good. Thanks. No, I'm trying to get going. Right. And what, you were eavesdropping, right? I thought I was talking to the computer. Versus there's, something is busted, in the classroom. And the sooner you can know about it, perhaps if you're available, the better it is. So I think it's a very kind of interesting question. There could be so many ways in which that could play out, positive or negative. I don't know what to think about that.
I was imagining like the best possible service, right? Like they ask their question, and then the bot is actually just stalling for time as it tries to answer their question, and the human is racing over to that room, and then the bot says, I'll be there, I'll be right there. And then the human walks in 2 seconds later and solves the problem, but also, if you've got this going over to an API endpoint, have you thought about connecting the room's AV equipment to PDUs that let you turn on and off the power to individual devices in the room so that you could reset the AV equipment that's having trouble just based on someone chatting about it?
Well, let your bot touch the other end of the cable, conceptually speaking, maybe almost.
Right. That would be an interesting idea, though. Currently, especially with all of, how much a bot can be manipulated, trying to connect anything physical with a bot like this seems like a very scary idea to me personally. Like, I wouldn't want anybody to potentially have, possible access to any AV equipment, or they can flip relays to turn on and off equipment while a class is running. Personally, to me, seems like a very dangerous idea currently. But having some control where someone could say, walk into a classroom and, Star Trek style, like computer turn the system on or something like that. I can see that being could be a very interesting thing for future use, so long as it can actually be secure.
Yeah, maybe it's gated by an additional check as well. Like maybe you've got a webcam that's pointed at the front of the AV equipment and sees the red light, and then if and only if the red light was on, then it allows resetting the thing, because the light's supposed to be green. It's always supposed to be green, of course, right?
Sure.
Things like that, which might seem crazy, but actually it's the technology that you are expecting to be working anyway. You're expecting a webcam to work in that room. You're expecting audio or video, or all these different technologies to work in that room, networking. So if you rely on those same technologies, you might be able to make something that's really amazing.
Yeah.
And yeah, sure, scary too. But if you, for example, can't ping that device, one of the pieces of equipment there, and they're already asking about it, well, yeah, why not remotely turn it off and on? But if they didn't ask about it, then they must not need it. Things like that.
It's a super interesting idea. If you could really restrict what was possible to particular things, yeah, it's pretty interesting.
Yeah, we currently, for more and more of our AV systems, we currently have some cloud software that we can use to remotely monitor devices in the classroom. So, in terms of restarting devices or checking the status of devices, we could very easily see, linking an API of that up with a chatbot. That'd be very possible to do something like that.
I like to think where this could go with visual input and not only, you mentioned control, but like there's cables, there's stuff like obviously it's a little ahead, but I mean, there's GPT-4 with vision. Like if there was a way for GPT to get to see the space. Oh, I can see your cables plugged into the wrong thing, something like that, right? I mean, that would be.
I've done little things like that. Well, that is to say, have a very different kind of bot where if I send a message, it sends it to a classifier, which makes text, detailed text description, which sends that as a behind the scenes prompt to the LLM, and then it responds to that. So,
Nice.
but yeah, yeah.
Yeah, initially I was toying around with that idea a bit, or somehow linking like Dolly up with a GPT that, could describe like if a bot says like I don't know what a gooseneck microphone looks like, or things like that. But at least in the phase that Dolly was out when I was testing that, it definitely was not returning some of the descriptions of some of the things I was asking for, like a gooseneck that looks a bit more like a Picasso rendition of a gooseneck microphone as opposed to what it actually looks like in a classroom. So, but yeah, having some sort of image verification or linked in with a bot seems like there's definitely a lot of potential to even greater like expand a tool like this to better serve somebody in a classroom.
I'm curious if there's anybody else in this group that's working on something like this or thinking about something like this for their department. Any interest out there? Use cases?
I've done some thinking about routing of support tickets. Like when support tickets come in, it's oftentimes that the AI would give the wrong answer to a support ticket, and it's too wild and woolly, the kind of the options, all the different possible things that someone might ask about in a support ticket. But if you allowed it only to classify which bucket to send it to, you could save a lot of tier 1 time and immediately, or more quickly get it to the right team so that the waiting time for the customer would be shorter. So even if you weren't going to answer the question, or potentially draft an answer to the question and have that sitting there in the notes in the ticket. So here's the question that came in. Instead of going to tier 1, having tier 1 try to triage it themselves, maybe it's a little bit. Some of them would go to a bucket that would still go to tier 1, but many of them that are kind of the automatic escalations that they never do any follow-up on, and then sending those right to the tier 2 team that's responsible, and maybe having it suggest some answer or some follow-up questions and those kind of things. I've been thinking about that, and it seems like that could be really useful here. But we also have like way too many trouble ticketing systems. Like I'm from a school that had one, like 80 plus help desks consolidated to one. Here we have like tons of different things, like not just ServiceNow, we even have 2 ServiceNows. Like and then we've got all kinds of other ones too. So like having like one point of entry to and then the tickets come in and they get all sorted to which team they go to and stuff, and maybe having some help. Yeah, you could write that for one of the instances, but then there's still like tons of other ones here. So our design is pretty distributed. So it'd be hard to fix problems in a scalable way when there's just so much diversity of solutions that are being.
But before our time's up, I wonder, Eugene, I wonder if you could just give us your thoughts at a broader perspective. Thanks for joining us today. If you have any just impressions or things you'd like to share or comment on.
Sure. This discussion has been a lot about the details, but I think we should take a step back and say, like, this is really cool. I think it's really cool that an employee just said, let me see if I can do this, right? And I wish more of our employees would feel like they work in an environment where that kind of behavior was encouraged and supported. We are very, what happens if it goes wrong kind of a place to work, as opposed to what happens if it goes right, or we'll try it, we'll pilot it, and we'll learn how to get it right by making mistakes. And so for those of you who are considering doing other things, or who know people are encourage them to do it and to try, because the reality is, even if we do it and it makes mistakes, nobody's getting in trouble. Nobody's getting fired. It doesn't happen. Some people are really going to wring their hands about it. And oh my gosh, we need to really push forward. I am particularly supportive of all this kind of stuff in our own unit. So we all of my leadership team, we pay the $20 a month to have ChatGPT 4. And I ordered them, everybody's got to use it for their work. You just have to. Right? There was no campus process or approval, but we can't be left behind. One of the things we specifically wanted to do was to load all campus policies into ChatGPT and create basically a bot so that you can query policies. And with the version we have, you can only load a certain number of documents, so it's not enough to cover all the policies. But something like this, we should have it. We should do it like the Triton GPT somebody mentioned. And so I want to have their GPT or whatever we call it that does all of the exact same things. There's no reason why we shouldn't have it. But I think these little experiments, as many of them as we can do, we should absolutely be doing them, because I think we can't rely on campus leadership to pull us along. We have to really push them along. And part of it is by, one, it's happening. Two, look at these neat things we can get it to do. There's a committee, the provost is forming a committee, something on AI, a governance thing, and wants us to be coordinated and all that stuff, which I find to be laudable, because we don't want to have 5 enterprise licenses for something, right? Which we do sometimes, really, really dumb. So coordination, yes, but I'm concerned about the governance being a gatekeeper to ideas and innovation. Well, these 12 people didn't sign off on doing this thing, and so or 8 of the 12 objected, and so we can't. No, so I encourage you to continue to move forward, particularly in this window of time where there are no real roadblocks other than your direct supervisors saying no. And if people who need support or want support, pushing stuff ahead, I am happy to have a conversation with people to help make this happen. But I've worked closely with Bill Allison on a lot of these things. And he's of the same mindset that we need to start trying these things. And also it makes it a more fun place to work for people who get to try to do stuff like this, right? We're not paying you enough and all the things that but hey, we get to be innovative in work, not just the folks in research labs. The people who work here, we can innovate as well too. And so I certainly greatly encourage this.
Thanks, Eugene. Yeah, great things to think about. Yeah, lots of good stuff. Yeah, thank you. Thank you very much, Amina, for sharing this work, and thank you for folks who've joined. And I'm sure people can, feel free to email and chat, whether to you or the AI community, or I'd love to, if people are working on stuff and want to talk about sharing it, even if you're just kind of playing with stuff, Jake and I are, we need topics and speakers, so just feel free, and thanks again.